Assalamualaikum warahmatullahi ta'ala wabarakatuh. So now I will present for the chapter 3, which is discrete time signals and systems in digital signal processing. There are several classifications of discrete time systems. So the first one is static vs dynamic systems. Second one, linear vs non-linear system. The third, time invariant and time variant system. The fourth, causal vs non-causal system. And the last one, which is stable vs unstable system. Next, we go for the first one. First one is static system. Static system is the output depends only on current. For example, y(n) is equal to a multiplied with Sn. The output at time n is simply the input at time n multiplied by a constant a. There is no dependence on past or future input value. And the second one is yn is equal to Fn plus b. The output at time n is the input at time n plus a constant b. It is dependent only on the input at the current time. And then dynamic system. The output depends on past or future input. For example, yn is equal to Fn plus a multiplied with yn minus 1. The output at time n depends on the current input Sn and the previous output yn minus 1. Parameters are the means, the influence of past output. And then we go for the linear vs non-linear system. The linear system is the principle of superposition applies. For example, yn is equal to n Sn. And then use the superposition. So after the calculation, we get this system is linear because it satisfies both superposition and scaling. After that, this is the non-linear system, which is principle of superposition does not apply. For example, yn is equal to a Sn plus b, and then we try using for the superposition principle, we get the result is not same. This system is non-linear because it not satisfy both superposition and scaling. Now we go for the time invariant and time variant system. The system properties do not change over time. For example, yn is equal to Sn minus Sn minus 1. As you can see, this system is time invariant because when we delay the input and the output, it gives the same results. Next, we're going for the time variant system. This system's properties is changed over the time. For example, yn is equal to Nsn. This system is time variant because when we delay the input and output, it gives the different result. So, we go for the causal vs non-causal system. What is causal? Causal is the output depends on the present and or past input. For example, yn equal to Sn. The output at time n is exactly input at time n. This system is causal because it depends only on the current input. Next example, yn is equal to Sn minus Sn minus 1. The output at time n depends on current input and the previous input. This system is causal because it does not depend on future input. Now we go for the non-causal system. The output depends on future input only. For example, yn is equal to Sn plus 1. The output at time n depends on the input at time n+1. The system is non-causal because it requires the future input value, which is at n+1. Now, we go for the last system, which is stable vs unstable system. For the stable system, a system is stable if every rounded input result in a bounded output. For example, yn is equal to ay n-1 plus bsn. This system uses feedback we get if the system output remains bounded for bounded input n. The last one, which is unstable system. System is unstable if every bounded input result are bounded output. For example, yn is equal to yn-1 plus ay-n-1. This system exhibits exponential growth in its response due to the positive coefficient alpha, leading to instability. So that's all from me. Thank you for listening.